All right, well, welcome and welcome to everyone else who's filtering in here. Let a couple of more people in, but hello everyone, good morning, good afternoon, good evening, good night, wherever you are in the world. We're really happy to be able to host another week of eoPERCS. And this week, our speaker is going to be Advait Jukar, who is currently at Yale University and is going to be talking about megafaunal extinctions in Southeast Asia. So before we get started, I'm going to do just a tiny bit of housekeeping. So first, we'd like to go over the format for this week's seminar, which is going to be very similar to previous weeks if you've been able to join us. First, I'm going to give a quick welcome as well as a few announcements, which is what you're hearing me do right now. And then Advait will give his talk, which will last about 30 minutes. We'll follow this up with a moderated question and answer session, which will last about 10 to 15 minutes. And then Advait will be able to join us for sort of an informal after-talk tea time if you would like to stick around and speak directly with him and with each other as well. And because we do have a moderated Q&A, please don't forget to send your questions at any point during this talk to us via the chat to the questions at eoPERCS host. So eoPERCS is a seminar values the participation of all folks interested in the paleo sciences. And so part of that is we do ask everyone here to abide by our code of conduct. You should have signed on to our code of conduct when joining our mailing list. If you've somehow managed to get into the seminar today without having signed our code of conduct, we do ask that you take just a couple of minutes, go to our website and make sure that you do read and agree to that before participating today. You should be muted now, and we do ask that you, at this point, you stay muted for the duration of the talk. Even if you find that you are able to unmute yourself. And again, you can at any point ask questions by chatting to the questions at eoPERCS host, which is Chrissy today. Also, if you run into any technical issues with the seminar, with Zoom, or anything else, those can also go to the questions at eoPERCS host. We are now using Zoom's built-in closed captioning system, which you should be able to turn on and off by clicking that little CC button, either at the bottom or the top of your screen. And we do ask that if anyone can think of other amazing early career researchers that they would like to hear from as part of the eoPERCS seminar, you can nominate folks, including self-nominate, at our website with the link right there. Finally, we do have a optional Survey Monkey, which we use to collect a little bit of demographic information. It just gives us a little bit more knowledge about who is able to attend these seminars in the community that we're working with. So we do ask that if you have a minute or two, you could fill out that seminar or that survey for us, even if you have filled it out previous weeks, and we'll drop that in the chat in just a second. So my final announcement today is actually a very special day for eoPERCS and the committee. Today is our 1-year birthday. It was a year ago today that we decided to form the seminar series that you are all an integral part of now. So we wanted to take a minute to celebrate ourselves and all of you and this amazing community that is built up around eoPERCS, and say happy birthday to the whole community. And with that, I can now introduce Advait Jukar, who is our speaker today. Advait did his bachelor's at Reed College and then his master's and PhD at George Mason University before moving to a postdoc at the Smithsonian National Museum of Natural History. Excuse me. Advait's currently a postdoc at Yale and the Yale Institute of Biospheric Studies. And with that, I think I can hand over my screen share as well as the floor to Advait.
Thanks, Kate. All right, can everyone see this? Yeah, we're good? Great. Thank you so much for that fantastic introduction. It's such an honor to be here on eoPERCS' birthday, giving a talk on large extinct things from India, which is something that I deeply care about. If you think about large animals, the first place that comes to mind is probably not India. It's probably going to be a place like Africa, where you have animals like elephants and lions and giraffes. And in fact, if you come to the Indian subcontinent, you've got a lot of extremely large animals like the gaur, the Indian wild water buffalo, nilgai, which is a giant antelope, large species of deer, wild ass, rhinos, elephants, tigers, and lions, of course, the famous big cats. If you look at the modern distribution of large animals, they're mostly found in only two places on the planet. They're found in parts of Africa, and they're found in South and Southeast Asia. But it wasn't all that long ago that large species were found everywhere on the face of the earth. For instance, you had large species like mammoths and mastodon, horses, saber-toothed cat, and bison in North America. You had animals like glyptodons, megatherium, elephant relatives in South America. You had rhino-sized marsupials called diprotodon and the marsupial lion in Australia. In northern Eurasia, you had animals like the woolly rhino, the woolly mammoth, giant deer, cave bear. Even in Africa, you had species which are no longer found today. Animals like the longhorn buffalo and the strange wildebeest like Rusingoryx. Southeast Asia had a species of giant tapir and a species of proboscidean called stegodon. And the oceanic islands also had giant ground sloths, large birds like the moa and the elephant bird, and a human-sized lemur on the island of Madagascar. But if you take a look at this map, you'll see that there's one giant blank spot, which is the Indian subcontinent. And for a long time, we didn't know about the recent faunal history of this part of the world. And this is what I'm interested in. These extinctions are collectively called the megafaunal extinctions. And they're called this because large species disproportionately go extinct over the last 50,000 years. The median size is about 182 kilograms for an animal that goes extinct around this time. Now, these extinctions don't take place at the same time. They're time transgressive or staggered over the last 50,000 years or so, with the first extinctions taking place in Australia and parts of Northern Europe. And the later extinctions taking place in the Americas and on oceanic islands. What's noticeable, though, is that even though there isn't a clear pattern of extinction through time, the extinctions all take place after the arrival of our species, Homo sapiens, on the landscape. But where does India fit into this context? And this is the question that I set out to answer a couple of years ago. So what do we know about late Pleistocene animals in India? Well, we've actually known about fossils from this period of time in the Indian subcontinent for over 100 years or so. And the first fossils were discovered by Europeans in the 1830s when the British ruled large parts of India. Here's a map showing the Indian subcontinent in 1837, and the areas in pink are the parts of India that were administered by the Brits. The first vertebrate fossils were found by this guy named Hugh Falconer. He was a Scottish naturalist who went up to the Sivalics and found this huge cache of mammalian fossils, which he then reported in the Journal of the Asiatic Society of Bengal. James Prinsep, the then secretary of the society, got so interested in these fossils that he wanted to know if similar finds could be made elsewhere in the subcontinent. So he puts out an ad in the journal. And this ad was answered by a colonial doctor named G.G. Spilsbury, who lived in central India in the Narmada territory, out here in pink. And he goes along the course of the river from the towns of Jabalpur down to Narsinghpur and Hoshangabad, and starts finding lots and lots of fossils that he starts sending back to the Asiatic Society in Calcutta. He finds so many of them that he starts labeling them on the maps that he draws of the region. So here you've got an inset of this map with 3 spots on the river where he's listed fossil bones, a fossil horse, and a fossil elephant. Some of these fossils were used by local Indians as tools of their trade. This is a palate and a third molar from a large elephant called Paleoloxodon pneumaticus, which was used by an Indian washerman or a dhobi to wash his clothes. It's a large flat surface, and he would beat his clothes on it in the river. Now, this specimen then ended up at the Asiatic Society, and like many of the specimens, either ended up at the Indian Museum in Calcutta or at the NHM in London. And from these early expeditions, we have a list of about 16 extinct species from central India. We got carnivores like the bear, or Ursus pneumaticus. You have rhinos and horses. You've got elephants. You've got artiodactyls, like species of large cattle, deer, pigs, and even hippos. There was a lull in exploration until 1883, when Robert Foote went down to South India to find evidence of early man in the subcontinent. And he was exploring these caves called the Bilasurgam caves in the Indian state of Andhra Pradesh, which is where he found another large deposit of fossil bones that were then described by Lydecker in 1886. And this is the first time that we can see evidence of extinct small species, animals like primates, civets, carnivores like hyenas, porcupines, rhinos, pangolins, pigs, and deer. There was again a lull in exploration post-independence. And then Indian archaeologists and paleontologists started to explore central India once again for evidence of early man. And they started to find fossils like the extinct stegodon. They started to name new species of extinct mammals as well, like a new species of hippo, a species of cave bear, a species of buffalo. More recently, colleagues of mine from Yale named a new species of water buck from late Pleistocene deposits in Western India. Wasn't until the late 2010s that people started to synthesize some of these records and collect information on their ages to understand how faunal dynamics are unfolding in this part of the world. This is a study by Robert et al. In PNAS, which looked at these cave sites in South India, once again, in a chronostratigraphic context. And they only found one extinct species, Therapithecus gelata, which is the extant gelata baboon, which is found in parts of East Africa, in layers dating to about marine isotope stage 5. So that's between about 125,000 years and 74,000 years ago. Then I got the first direct date from an extinct megafaunal species in the subcontinent. Colleagues of mine and I dated an incisor, a canine of a hippo from central India, and then created an extinction chronology for the species. So this showed that there were more extinctions than had previously been thought about, but no one had looked at the larger context of the extinctions yet. So that's a question that I was interested in. But to first get at this, I had to figure out who actually went extinct in the last 50,000 years. And that required a taxonomic survey. So I collected all of the information that I could from the 28 extinct species named to date from India. And then I assessed whether they had good age control, whether their taxonomy had been revised, and whether there was even enough material to justify naming them as a species. And it turns out most of them had poor age control. Some of them had been synonymized with either extant species like Rhinoceros corneliensis, which is now thought to just be rhinoceros from the Indian subcontinent, Rhinoceros unicornis. Cynocephalus, which was named by Lydecker from the sorghum caves is now just thought to be Therapithecus gelata. And a lot of species were named after very scanty remains or crushed specimens, which are not good for taxonomy. So based on all of this, I came up with a list of about 5 species that are no longer found in the Indian subcontinent. We can take a closer look at them. You've got 2 species of Proboscidean. You've got Paleoloxodon pneumaticus, the straight-tusked elephant, and Stegodon pneumaticus. You have Bos pneumaticus, the Indian auroch, Hexaprotodon, which is a species of Indian hippo, and Equus pneumaticus, which is the Indian zebra. Now, Paleoloxodon was one of the largest species of Proboscidean to ever exist. It's about twice the size of an African elephant. And that's me with the skull from one of these animals in Calcutta. And I'm about 6 feet tall, so you can just get a sense of how big these elephants were. Stegodon were these massive straight-tusked elephants with roof teeth or roof cusp teeth, known from South and Southeast Asia. It's a very long-lived lineage, and they're also found from the late Pleistocene of India. This is a skeleton of one of these stegodons that was found in central India by a colleague of mine. Equus pneumaticus is what I call the Indian zebra. There are 2 kinds of horses. There are Stenonian horses and Cabeline horses. Stenonian horses are characterized by a special V-shaped cusp of enamel on their lower teeth, and that's what you find in Equus pneumaticus. And this enamel cusp is also found in extant zebra, which is why I'm calling this species the Indian zebra. Hexaprotodon is the 6-toothed hippo, as the name suggests. There are actually 2 species of Hexaprotodon known from late Pleistocene deposits. They can only be distinguished by the size of the second incisor in relation to the first and the third. So unless you find an intact mandible and you date it, it's actually hard to know which species you're dealing with. And so I classified all of these as just Hexaprotodon spa. The Indian auroch is the wild type of the modern zebu cattle, which is found in the Indian subcontinent. This represents a pseudo-extinction because this lineage persists in the domesticated form today. In addition to these mammals, I also found a lot of occurrences of ostriches in the form of eggshell beads and etched shells. And this is the same species of ostrich which you find in Africa today. Now, we know that these species go extinct, so is there a large size bias to the extinctions that we see in India, much like we see elsewhere on the planet? Well, it turns out all of the extinct mammals are large, and they tend to be significantly larger than the species that persisted. And we only see 4 true extinctions, which represents only about 4% of the terrestrial non-volant mammals in peninsular India, and only about 15% of megafauna, that is mammals weighing over 50 kilograms. Now, when do these extinctions occur? We know these species lived at some point in the late Pleistocene, but what was the pattern of the extinction? To figure this out, I collected as much information as I could from dated sites from the last 50,000 years, which is the extinction window seen globally. Of these 52 sites, 24 sites preserved extinct species. And I constructed extinction chronologies for all of these taxa, the 5 mammals and the ostrich. Because the fossil record is incomplete, you never find the last known individual of a species, which is what a true extinction is. To account for that, you can analytically estimate the extinction time using a technique called the Gaussian resampled inverse weighted McLerney method. And what this technique does is that it takes the gaps between individual dates and it upweights more recent dates, and then it projects when a species could have gone extinct. You can do this when you have 5 dates or more, which was possible for the horse Paleoloxodon, the ostrich and the hippo. Stegodon only had 3 dates, so I couldn't estimate the extinction time for this species. And I chose not to do this for Bos pneumaticus because it's a pseudo-extinction. The last appearance date for Stegodon is at around 30,000 years. The next species which go extinct are the Indian zebra and Paleoloxodon in the terminal Pleistocene, and the ostrich and the hippo squeak into the Holocene. The last appearance of the wild type Bos pneumaticus is seen at about 5,000 years ago. So this gives us an extinction window of about 22,000 years. So what else is going on in the Indian subcontinent at this time, climatically and anthropogenically, which might help explain these extinctions? To do this, I compared the extinction window and the extinction chronology to 2 climate curves. The first one, which you see on the left, is the oxygen isotope curve from the Greenland ice core, which is a proxy for Northern Hemisphere temperature. It's warmer on the left and colder on the right. And the curve on the right is a speleothem oxygen isotope curve from northeastern India, which is a proxy for monsoon intensity. And on the left, you've got strong monsoons, and on the right, you've got weak monsoons. The extinction interval between about 30 and 8,000 years corresponds with 3 particularly cold and dry periods of time. You've got the LGM, or the last glacial maximum, which is the maximum extent of the Northern Hemisphere ice sheets, and it got pretty cold then. You've got the younger, driest cold snap, and you've got Heinrich Event 1, which was a particularly cold period, and more importantly, a particular dry period in South and Southeast Asia, characterized by these massive droughts. But if you look at the climate curve before these 3 events, it's pretty squiggly, characterized by a lot of periods of strong and weak monsoons. It's an oscillating cycle, and these species have persisted through there. So we know that these species go extinct in a period of climatic variability, but we know that they can also survive this kind of climatic variability. All right. What's going on with people in the subcontinent at this time? Well, our species shows up by at least 60,000 years. The earliest archaeological evidence comes from sites in South India and Sri Lanka, and can be dated to about 48,000 years. And the first fossils of Homo sapiens show up at about 30,000 years. But we know that the extinctions correlate with a period when tool technologies are changing. We see a shift from older Middle Paleolithic tools to more advanced microliths, which are these small projectile points, which are thought to be more efficient things like arrowheads or spear points. And at the same time, we're also seeing increases in human population size. Between about 45,000 years and about 10,000 years, South and Southeast Asia had about a third of the world's human population. So these extinctions are taking place in a world where people are increasing their populations and are becoming increasingly sophisticated in their hunting technologies. So based on all of this information that I've gathered so far and the data available to date, we can conclude that India experienced a low magnitude but highly size biased extinction. Low magnitude is strange because large parts of the world experienced a high magnitude extinction. But like the rest of the world, India also experienced a size biased extinction. The extinction, interestingly, takes place thousands of years after the arrival of Homo sapiens on the continent. The extinctions in the Americas take place only a couple of thousand years after the arrival of our species. And the extinctions coincide with fluctuating rainfall patterns, increases in human populations, and technological change. So if we put these extinctions in the global context, we see that they fit the general pattern of taking place after the arrival of our species. But interestingly, the low extinction magnitude is only seen in one other part of the world, which is the continent of Africa. So what explains this persistence? Well, one hypothesis that has been put forth for the persistence of large mammals in Africa is that these species co-evolved with humans. Our lineage originates in Africa, and so do the lineages of all of the species which persist in Africa today. So these species may have adapted to what humans are doing on the landscape, whether it be land use change or it's hunting. But it turns out India also has a long history of hominid occupation, going back almost 2 million years. Here's the only fossil non-Homo sapien hominid from India. It's a skull cap of a species of Homo from central in India, and it's possibly Middle Pleistocene in age. But we have tools which go back almost 2 million years in South India, and it's an almost continuous record of these tools, suggesting that there were multiple species. And there's an interesting pattern which emerges globally, that places which have a long duration of hominin cohabitation and places which have multiple species of hominins tend to have low extinction magnitudes. And all of this tends to support this co-evolution hypothesis. We know from sites in Sri Lanka that humans were hunting small game, so it's possible that people may have had a higher diversity of subsistence patterns in the subcontinent, which would have aided in the survival of more large species. It's also possible that a lot of these large species that survived because they had robust metapopulation networks. We know that range size tends to correlate with extinction risk, and species which have large geographic distributions and strong source sink dynamics tend to persist a lot longer. And a lot of species which persist in the Indian subcontinent today, animals like the Asian elephant, once ranged from Turkey to China and Southeast Asia. And from molecular studies, we know that they occupied glacial refugia in parts of South India, Sri Lanka, and Southeast Asia, and then came in and repopulated parts of the subcontinent. The species which go extinct in India were endemics, and it's possible that they lived in small fragmented populations. And when you have small fragmented populations living in fluctuating environments, and these species tend to be slow breeding as well, it doesn't take a lot of anthropogenic pressure to push them over the edge. Indian ecosystems show a great deal of continuity from glacial times to interglacial times as well, suggesting that these ecosystems were more resilient to environmental change than in other parts of the world. And similar patterns are seen in Southeast Asia as well, where we also see a low magnitude extinction. A recent study by Julian Lewis and Patrick Roberts showed that only 4 species go extinct in parts of Southeast Asia, which has a similar environmental history to the Indian subcontinent. So I want to leave you with something that Alfred Russel Wallace said in 1876. He said that we live in a zoologically impoverished world from which all the hugest and fiercest and strangest forms have recently disappeared. And Wallace was talking about the disappearance of the megafauna. And we should care about this because these species go extinct in the very recent past. We just missed them. There were mammoths on the planet when people were building pyramids in Egypt. And today, large species are being increasingly threatened. Large species like elephants, hippos, and rhinos are increasingly being defaunated across their geographic ranges. We're seeing vast amounts of overexploitation from land use change, from hunting. And if this pattern keeps going on, the extinction that started 50,000 years ago with the extinction of the mammoth and Paleoloxodon will keep continuing on, and the largest species of land mammal will be a cow. And I'd rather not live in a world where we're not sharing our space with animals like elephants, rhinos, buffalo, and deer. So with that, I want to thank eoPERCS for hosting me. And I want to thank my co-authors and collaborators and all of the institutions that supported this research. Thank you very much, and I will take your questions.
Wow, thank you so much for that really wonderful talk. It's a really powerful conclusion that you're able to draw from this as well. So for folks in the audience, we would encourage you to continue sending questions to the questions at eoPERCS host, who is Chrissy, and we will be able to moderate those questions and ask them to Advait. So in the meantime, as we're waiting for a few more questions to come in, we do have some that came in during the talk. So the first question we have is, have you looked at extinctions in smaller bodied mammals in India as well?
Yeah, so we looked at the cave site, which is the only place where you actually have a good record of small mammals. And you either have small mammals going extinct before the global extinction interval, or there are just no extinctions after that. I mean, one of the conclusions from Patrick Roberts' 2014 paper was that there is a remarkable amount of faunal continuity in the subcontinent based on this one cave site. And the species which are found in this cave are still found elsewhere in the subcontinent today. So right now, we don't have a lot of evidence for small mammal extinction.
Oh, thank you. So the next question, thank you for the amazing talk. You mentioned fossil remains of extant African ostriches found in India. Is there any evidence of what the range might have been for other Pleistocene megafauna on the Indian subcontinent? Would there have been much connectivity with other African or Asian populations?
Yeah, we don't have a good idea about that yet. I think the only African species which we see sort of creeping into the subcontinent was the ostrich, but the gelada baboon, which is found in East Africa today, may have ranged all the way from Ethiopia to India. So that's a second species. There are the species of waterbuck, which was named by Liz Verba not that long ago, is part of a lineage which was found all the way from the subcontinent down into East Africa. So there is evidence of faunal continuity from Africa to South Asia. I think at the species level, we currently only have two examples of species which ranged across the two parts of the world.
Thank you. And I hope it's okay if I actually ask a follow-up on that. Do we know why the range of ostriches would have constricted since
you know? So we think that the ostrich expansion took place fairly late in the record, after about 74,000 years. So they seem to be a recent migrant to the Indian subcontinent. They may have just come in a wave and then gone extinct when people ate their eggs or exploited them as they exploited other large birds in other parts of the world. That's our best guess right now. I'm currently involved in a project to try to understand ostrich range collapse globally. So we might be able to answer this question in the coming years.
Thank you very much. Mm-hmm. So the next question we have, great talk. Do you think the extinction of the 5 species you were able to estimate were truly sequential? Or is it more a data artifact and the whole window is likely the extinction interval that these stages all fall within? I know there have been patterns of the biggest animals going extinct first and was wondering if you have enough data to talk about this for your data sets?
Right. It's a great question. Unfortunately, we don't have a lot of good data on these species. We need a lot more dates, and we need a lot more good direct dates on these species to get out a more nuanced understanding of the pattern of the extinction. Right now, I would say that these species go extinct between about 30,000 and 8,000 years ago, and that's based on the best evidence today. If we get new dates, that it might change that interpretation.
Thank you. So our next question is from Roy Plotnick, who asks, how well do we know the history of land use change in India? When did agricultural deforestation occur?
Yeah, it's a good question, Roy. So the first evidence of domestication and agriculture seems to go back about 10,000 years ago. I'm not sure about large-scale habitat change, but we know that people were building cities in the Indus Valley about 4,000 years ago. So I suspect sometime between about 10,000 and 4,000 years is when you started to see intensive agriculture in India.
All right. And another human question. So great talk. Do any of the fossil remains display evidence of hunting to support your conclusions on the main cause of the megafaunal extinction?
That's a great question, and that was part of my proposal at Yale. Unfortunately, I could not go to India to sample new sites or go to museum collections to look for evidence of cut marks. So stay tuned. Hopefully, I'll get to go there and find some evidence of this. So far, we have no convincing evidence of cut marks or butchery marks, but that's probably because people haven't looked. It's also incredibly rare to find butchery sites in general.
Thank you. So actually one more human question as well. It looked in your summary figure that Homo sapiens made it to Australia before their arrival on the Indian subcontinent. Do you think this may have happened? India seems far more accessible than Australia.
Yeah, so there's an ongoing debate about when people show up in the Indian subcontinent. There's a school of thought which says that our species showed up there at about 100,000 years ago. We have evidence of Homo sapiens from Arabia that date to about 88,000 years, from the Levant, which go back to about 120,000 years, and from China that are about 100,000 years old. So it's quite possible that our species was there in India by that time. We don't have any direct fossil evidence. I'm not a paleoanthropologist, but from my limited understanding of the tools which archaeologists use to correlate with our species, microliths first appear in the record at about 48,000 years, and molecular estimates place our species in the subcontinent by about 60,000 years. But we're seeing that tools don't necessarily correlate with a particular species of hominid. So it's quite possible that our species was there for a much longer period of time than just 60,000 years.
Wonderful. Thank you. Well, I'm not seeing any more questions come in at this point. So I'd like to thank you again for an amazing talk and for answering so many of our questions. And I'm going to go ahead and take over the screen share again.
Thank you so much.
Yeah. All right. So hopefully you can see my screen again here. So I just wanted to thank again everyone in the audience for coming to join us for our very special birthday edition of eoPERCS. And we hope that some of you will be able to join us again next week when we'll be hearing from Tali Babila about surface ocean warming and acidification driven by rapid carbon release, preceding the Paleocene thermal maximum. So for now, though, for those of you who can stick around a little bit longer to talk with us as well as Advait, we'd invite you to join us for tea time. So the idea behind Tea Time is just to get a chance to informally learn a bit more about today's speaker, their research path, and the type of work that they do. It's a chance to meet new friends as well as to bump into old ones and discuss the talk that we've all just enjoyed with paleo fans of all different backgrounds. And it's also just a chance to unwind and chat a little bit before heading back to your regularly scheduled day. So before we jump into tea time, we're going to give everyone a short break. Feel free to get up, stretch your legs, make yourself a cup of tea, and then we'll be back in about 2 minutes for an informal discussion. So hopefully we will see several of you in a couple of minutes here.